before we get started, we need to go over a few safety rules. Remember, safety comes first in everything that you do. Be sure to wear your hard hat, safety glasses, cut gloves, and sturdy boots. Inspect your hard hats for any cracks or damages. You also want to take a look at the date inside. Make sure that the hard hat is not expired. We want to check the ratcheting, and we also want to twist to see if it cracks. Please also check your gloves. Make sure they are not ripped and torn and the coating is in good condition. If your gloves look like these, we need to go ahead and replace them. With your glasses, make sure they are clean and scratch free. These again should be replaced by the foreman. Look at the bottom of your boots and make sure they still have quality tread life left, and see your foreman if any C. Davis issued items need to be replaced. Remember, the topics covered in this video can't cover all the areas or foresee all variances. This should only be used as guideline and not as a complete set of safety rules. There can always be special job-related safety requirements that cannot be covered in this video.
Greeting viewers, my name is Christian Cabrera. I'm an 11th year journeyman electrician. I work for C. Davis Electric. I'm going to show you a quick review of what a normal standard electrician should have on the site. First, I'm going to start with a multi-ratchet screwdriver, long nose trim screwdriver, flathead, lineman's pliers, strippers to connect and strip your wiring, standard pair of channel locks, standard pair of dikes or side cutters for cutting wire, an MC roto splitter, which I'll show you in the next segment how to properly use one for cutting MC, a torpedo level that's magnetic, standard pen tester to check for voltage or read voltage, a couple bits for your drill setup, multi nut driver and an extension magnetic bit, utility knife, and a marking tool, pencil, marker, any of your choice. I like to have a nice sturdy belt, something above the waistline, padded, holds a lot of weight. I use a Tough Belt. It's got a connecting system for your different type of bags and tool belts of your choice. And also a standard drill, impact, something that you can torque down screws when needed. A magnetic pouch, I want to say, that helps kind of keep your, your hardware together. That's a standard tool belt for an electrician. Welcome viewers. On this segment, I'm going to show you how to knock out a standard 1900 box and mount it to a already ran 1/2-inch conduit. First, you take your lineman's pliers, you pick the designated hole you want to use, hit it a couple times, take your pliers, spin it around till it drops. As electricians, you could drop anything on the floor, doesn't matter. Now you use this, stick your wires through. Grab your lock nut. Make sure it's tight. Now grab a Phillips driver to your drill. Grab your standard tech screws. Oh, I forget. Want to use your torpedo level, make sure it's nice and level. All right, now I'm trying to find my center point, making sure that simultaneously the box is level. Then I'm going to pick a screw hole. Make sure I'm torqued down, continuously staying level. Grab my second screw. Find a designated pre-made hole. And there you go. Box properly mounted on the wall. Greetings, viewers. On today's segment, I'll show you how to properly install an MC cable into a 1900 box. MC cable is a metal protected cable for usually wiring of various branch circuiting. Now first I take my roto splitter, insert it into the slot. You always remember, be mindful of the direction of the arrow on the blade. You don't want to spin it in the opposite direction, it will break the blade. Simultaneously as you spin, there's a grip here, you squeeze down. You'll find that you'll kind of feel the metal breaking. You release your splitter, give a couple spins on the metal, pull out, take your plastic with your Dykes side cutters, cut the excess. I'll take a 1mm bushing, or what we like to call any short, slide it in between the cable and the actual metal conduit. Push down until it's flush. I'll take your MC connector, slide the wire in, push the cable all the way till now I take my wire. Before that, I need to break a hole inside the box, which I showed in the last segment. Take your wire with your connector placed. Slide the wires through the hole. Now with applying pressure, I recommend holding your box. Push down until you hear all the clips click in place. So now after you've properly secured your connection with your MC to your junction box, you want to use a foot of clearance and add a 3/8 one-hole strap. Take your drill with your Phillips bit and a self-tapping Phillips screw. I'll take your strap with the foot of clearance. Properly secure your MC to your stud bracket. Now another method of securing MC cable through an open studded wall is to find a proper hole through your stud, which we have one here. Push your MC through the stud. Give yourself a serviceable loop, nothing too tight. Now we take standard piece of tie wire, metal tie wire. Once we've run our length, we take it and we try to wrap it around the stud and the conduit. Take our journeyman pliers and we want to simultaneously spin and pull, spin and pull, spin and pull. So you get a nice tightness to the wire. Cut the access, give it a couple taps down, and now we have demonstrated how to properly strap MC cable. In this segment, I'm going to properly show you how to trim a wiring device, switch, or receptacle. Before anything, you look at the box that you're going to wire this device into. You want to make sure it has a mud ring. In this case, we're going to install a single gang mud ring to this roughed in 1900 box. There will be drywall placed around this mud ring, so you don't want to fully trim it until the drywall is placed. Take your screwdriver, make sure you properly screw in your mud ring. After properly installing your single gang mud ring, you want to take your device, 15 amp duplex receptacle in this example, You want to take your ground wires that are already pigtailed off the box with a green ground screw. You want to take your number 12 gauge stripping hole on your strippers. You want to strip down all your green wires to about an inch wide. Take your 3 wires, using your head of the pliers. Give it a couple spins. With solid wire, you want to make sure you grip the wires really well. You don't want any gaps in between. Cut off the excess. Grab your red wire nut. You want to spin until all the wires spin in the same direction. While doing so, now I have a method of hanging my receptacle while I continue to wire my switch. Rule of thumb is, take your bare hand, put it against the box, stick your thumb out. It's about 6 inches to 5 to 6 inches of length you want on your wire. You want to take your strippers or your cutters, cut the excess off. Once again, you want to take about an inch off using your strippers. You want to grab the edge of the wire, give it a nice curl. Same thing with the neutral. And you want to take your gold screw, which is going to be your power or your line side. You want to take your strippers again, give it a nice squeeze to hug that screw real tight. Take your Phillips screwdriver, torque down so you feel it tight. With these receptacles, I like to use my flathead afterwards. Give it a tighter connection, more grip. Spin to the other side. You're gonna have a silver screw, which signifies neutral, which will be your white wire. Once again, take your strippers, give it a nice bend on the wire. Take your Phillip, spin down, double back with your flathead. Let's give it an extra more torque. Now I would take your standard electrical tape, white, black, any of your preference. You want to tape these connections. Due to it being hot at any point in the future, and someone needs to service this receptacle, being a metal box, you don't want to expose these screws. They could bump into the box and create an arc flash. So just to give protection, you want to wrap that with some tape. Then you want to take your wire nut, push it inside the box. Take your receptacle and carefully, watching the wires, push it down in so it gets closer. You want to take your screwdriver, you want to start screwing down on one of the screws. Get it into a position. Before you completely screw that down, you want to get the other screw into place. You want to spin down tight. Now, if you wanted to be a little quicker, you can get your drill with your Phillip bit and slowly and carefully screw down on the receptacle. Make sure it's straight. As well as while you're doing that, watch for the wires. Make sure you don't pinch them with your screw. You want to grab your trim plate, stainless steel or plastic, whichever. You want to line it up with your receptacle using your flathead screwdriver. And carefully spin it in tight. There you have it. That's how you properly install a 15 or 20 amp duplex receptacle. So now I'm gonna show you guys how to install a 15 or 20 amp single pole switch. First, you wanna take your wires. You wanna identify which wire is your hot wire and which wire is your switch leg or your light that will be powered. In this situation, our red is our power. So you wanna take your strippers and you wanna take about 2 inches of depth. You wanna pinch down on your numbered gauge hole. You wanna properly and slowly pull up a little bit to expose the bare copper of the wire, just enough to wrap around the screw, which I'll show you in a second. So take your 2 wires, 2 inches of depth with the number 12 gauge hole on the stripper, pull up to about 1 inch. Take your switch. In this situation, we're single pole switch. Both screws are gold. Polarity is reversed. It can be either or. So what you're gonna take is, you're gonna take your wire, you're gonna wrap the wire, bare part of the wire around that screw. And you always wanna put the hanging edge to the right side of the screw so that when you're tightening down on the screw, it keeps it in the same direction of the wire. Make sure it's properly tight. Take your second wire, wrap around your screw tightly. Once again, tail end to the right. Once again, you want to torque down so it's tight. I'm going to take our ground wire that's already pigtailed. Put it to your ground screw on your switch, which will be your green screw. Pinch the wire close, so give it a nice wrap around the screw. Take your screwdriver, torque down till tight. Here at C. Davis Electric, we like to use electrical tape to kind of insulate our devices and give them some more protection for the future. You don't want to pull out an outlet or a switch and hit a screw to a box and create an arc flash. So I'm done taping my device. I want to make sure that the device is properly in the up and down position, where you see your markings legible, not upside down. Then you want to take your switch, line up your screws to your muttering hole. Once again, give it a few tightened screws so you can line up your second screw, your 632. Now for speed and quickness, I like to use my drill to finish the rest. Make sure the switch is nice and straight, center to the single gang muttering. Once your screws are completely fastened, you want to take your plastic, in this instance plastic toggle switch cover. Once again, there is no drywall for the purpose of this example, but there will be if you were actually going to put it in real life application. Take your flathead. Take your second flat screw. Line it up. Tighten it down. There you have it, how to properly install a switch. In this segment, I'm going to properly show you guys how to splice a junction box Rule of thumb, once again, is we want to take our lengths of wire. I like to put my palm to the box with my thumb sticking out. That kind of signifies 5 to 6 inches of length. Anything past that, you want to cut free. Okay, then you want to take each end of these wires. In this case, all these wires are 12 gauge wire. You want to take your 12 slot in your strippers, and you want to cut off about 1 inch off each wire. While using the strippers, I like to angle them at about 25 degrees and pull up. Gives you a nice clean cut. Now with the solid wire that's in this box, due to the grounding screw, I like to spin those first. Using your pliers, like lineman's pliers or strippers, you want to give yourself a nice twirl around to where they're stuck together, as you see here. Cut off any sharpened edge. Now the stranded wires, you may need 2 hands for this. Stack them up together, keeping them all at the same length. Bring them in with the solid wires. You want to take a red wire nut or blue wire nut, whichever you need for the application. In this case, we're going to use a red. Once again, make sure they're all at the same height. I'll take your wire nut. You want to spin them. You want to kind of make sure that they grip all the wires together. Give it a couple twirls. Nice and tight. Now you want to take your next wire, which I'm using now as my neutral. So you want to take all your whites together. Once again, measuring stick. I'm going to strip each end to about 1 inch. 20-degree angle helps with the cut. Line them up. Make sure they're both parallel. Grab your second wire nut. You want to give it a spin until the actual wires twist together physically. Now for our last wire, I'll take your red measuring method, cut your excess, strip each end 1 inch. Line up all 3 wires, stack them up nice and neat. Take your wire nut, and once again, you're going to spin them so physically tight. Once you're done splicing completely, you want to properly insert your wires. Be mindful. You don't want them to jumble up or be crossed together, because you want to be able to service this box in the near future. I'm going to start with 1. Usually I take the ground, properly push it in the box. I want to take another wire, red or neutral, whichever your preference. I want to tuck it again, keeping them away from each other. You don't want them to be all intertwined in case of a wire nut or something were to loosen at times. You don't want the wires to interact with each other. Then you're going to take your 1900 blank in this situation for your 1900 box. You want to place the blank in the direction of the slotted screws. You want the notch in the plate to be facing down so that gravity doesn't take the plate. Take your Phillips screwdriver and screw down your 1032s. And there you have a properly spliced junction box. Welcome back. Today, in this segment, I'll be showing you how to properly land wires and breakers in a panel. Before anything, you want to make sure that wherever you're landing your wires, that you're running them and organizing them in such fashion using tie wraps. Before starting, you want to make sure that your panel is dead, that you have no live conductors or any current running through this panel. And once you finally check that it is dead, you want to now take your wires, place them in a direction or numbered fashion. So for instance, this will be number 1. You want to strip your wire down, 12 gauge as well. I like to give it a nice little spin, keep the hairs on the wire together. You want to always make sure that your circuit breaker is off. Even though the panel is dead, you always like to keep everything off in the off position before making live. I'm turning these 2 breakers off. You want to take your Robert's head tip for square D breakers. You want to loosen the screw up a little bit just to keep enough gap for you to slide your wire right in. You always want to visually check, make sure that the wire is in properly. Take your Robert's head screwdriver, torque down. Now this is not going to be something that you're going to torque very hard. You want to just torque it enough where your hand strength gives it enough tightness where if you pull back, the wire doesn't slip out. You want to make sure you identify the bar, neutral bar that's in the designated panel. In this case, this black bar here, left side. You want to find a designated hole. First, you want to loosen up the screw. Slide your wire in completely until you could see it popping out on the other side of the screw. Take your Robert's head screwdriver and torque down until hand tight. Now I want to take my ground wire that I have ran to the designated ground bar. Once again, I want to take my Robert's head screwdriver. I want to loosen up a termination screw. Slide my wire into position. Make sure the wire passes through. Take your Robert's head screwdriver once again and you want to torque down. Until hand tight. We'll go back and we'll wire up our number 3 circuit. Strip number 12 gauge. Give it a couple spins. Take your Robert's head once again. Loosen up the screw on the breaker. Just enough to slide that wire right into place. Come back with that Robert head screwdriver. Torque down till tight. And I'm going to take the neutral for that number 3 circuit. Strip it down once again. Pick a designated screw in my neutral bar. Loosen enough to slide the wire through. Make sure the wire sticks all the way through. Torque down till tight. After you've properly landed your circuits in their breakers, you want to take your number book. You want to label each of your wires to their designated numbers. Left side of the panel is odds, right side is evens, starting from 1, starting from 2. In this instance, we're going to be labeling 1 and 3. Take your number, take your wire, give it a few inches off the breaker. You want to take that neutral as well for that designated circuit. You want to both label those both 1. Take my number book again. Take number 3. Once again, a couple inches away from the breaker. Tear off half. Find the neutral. Label both of those. And now you have a properly terminated and labeled panel. Welcome back. In this segment, we'll be talking about how to properly wire lighting fixtures. Right here in front of me, I have a 2x2 LED fixture. First thing you want to do is you want to identify your concentrics or your knockouts. In this fixture, we have 2 different locations depending on variables. What I'm going to do now is I'm just going to remove the plate from the fixture using a Phillips head screwdriver. Take the plate off. Identify your wires needed to splice. Your black, your white, your green. Now, for training purposes, will be a replication of your branch wiring for your lights. You want to take your MC with your knockout. You want to take your plate. You want to put the MC inside properly. Once you've secured the lock nut, you want to place the cover near the wires that you're using to splice. You want to put your greens to your greens. I'll make sure they all line up properly. Take your yellow wire nut. Make sure you spin correctly. Take your black wire, match it with your other black wire coming from your MC. Make sure that the wires make good contact. Spin tight with the wire nut. Grab your white wire as well. Line them up as such. Make sure they're spun on real well. Take your yellow wire nut, give it a nice twirl. Okay, you want to take your 3 wires. You want to carefully place them back inside the fixture. You have a slotted part of your plate that you want to slide underneath the fixture. Line up your screw hole. Take your Phillips head screw with your driver or screwdriver. Spin tight. Make sure that everything is secured. And there you have the proper way to wire up a lighting fixture. Welcome back. Here in this segment, we'll be talking about tools. What you see on this table are more or less the tools that you'll see on a job site. I'm going to start with our hammer and drill driver. This is used to cut most holes or drill in most materials in a job. I'm showing you an example of how to properly secure a bit to the drill. First, you want to release the chuck. Put the bit inside and then tighten the chuck back down. Big safety tip. I like to put all my attachment pieces to all my power drills before I actually install the battery to it, just to keep from safety, just to make sure I don't hurt my hands while I'm installing them. Now, if you hear a ratcheting click onto this drill, it's meaning now that it's fully tightened. What I like to do is I slightly pull back 1 click and that locks in your attached piece. And sure enough, once it's attached, you have your reverse and your forward. And you also have your different levels. You have your drill, you have your hammer drill, and you have your different levels of torque. 14 ranging all the way down to 2. Next tool, reciprocating saw, or what we like to call Sawzall. Now, to install this blade, you're gonna have a lever here, as you see. You wanna pull back with all the pressure, and it's gonna open up a pin that's inside this receiving end. You wanna stick your blade inside. You wanna release that lever, and then you wanna pull back on your blade to make sure it's completely tight. Once again, you put your battery in once you've attached your attachment piece, and you're ready to go. Next tool, we're gonna use this smaller core bit with an 1.5 inch diameter. You're gonna slide the bit down and you're gonna spin clockwise. Now we use this to pilot a bigger hole when we need to go through multi-slab or multi-material applications. And obviously this is a corded one. You would plug this into power, you would hold it straight and even, and you slowly make your way through. Now very careful. Some other equipment, like the one I'm gonna show you next, has new technology that's made to auto stop whenever there's tension in your cutting. This tool is a little old school, so you have to be very, very careful. If you do feel tension, you do feel a kickback, you wanna release the trigger and reposition your drill and continue drilling. Moving over to the next piece of equipment, which is also a core drill, but this is for a bigger core bit. Once again, same style of applying. You take your 4-inch bit, you're gonna spin clockwise. Keep in mind, I always like to put my batteries or plug in my equipment after I've attached my piece. Want to slide your battery into place. Adjust your handle accordingly. Position your core bit to the angle needed. Turn your power button on. Now, while using this, there is an attachment piece that you're able to hook up a hose bib to create water flow through your drill to reduce dust or pollen in the air. And there you have it. These are simple tools that we use on our day-to-day.